So we've got here our squares are interesting critters. Today we're going to explore the relationship between the area of the square and the lengths of its sides. Let's take a look. So this first square here has side lengths of 1. We can see that that side length is 1 and that side length is 1. And that the total area of the square is 1. And so we're going to be looking for patterns and recording what we see down here. So if the side length is 1, the area is 1. And the other example that we have there is a side length of 4. So side lengths of 4 produce an area of 16 because 4 times 4 is 16. So if I find this square that has a side length of 4, its area is 16. All right, and so we're asked to fill out this table with the rest of those squares. And so a side length of 2 by 2, here's a square that's 2 by 2. And its area is going to be 2 times 2, which is 4. Next, we need a square that's 3 by 3, and as we count these, we're counting the spaces, not the dots. And so 1, 2, 3. I know it takes 4 dots to do that, but that's 3 spaces. And 3 by 3 would make an area of 9. 5 is our next one since we already have 4, so 1, 2, 3, 4, 5. 1, 2, 3, 4. Oops, not going to work. It's this whole thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so if we had a 5 by 5, that would be 25. Now we don't have a big enough square to represent 6 by 6, so we're just going to recognize that 6 by 6, if we had a square that was 6 by 6, its area would be 36. Because 6 times 6 is 36. So now we're going to go through and look for patterns in what we see happening. So I'm noticing as I look at this that when I multiplied the side lengths, both side lengths were 1, and they were the same because it's a square. 1 times 1 was 1. I noticed that 2 times 2 makes 4, 3 times 3 makes 9, 4 times 4 makes 16, 5 times 5 makes 25, and 6 times 6 makes 36. And so I'm seeing that if I multiply the side lengths and get the area, I'm always going to be multiplying the same numbers. So like a 5 times 5, 6 times 6. So the area of the square is the side length times itself. And so again, we can see 5 times 5, 3 times 3, 2 times 2, 6 times 6. All those examples. We're just basically multiplying the length of its side by itself to get the area of the rectangle. That's an interesting pattern. And so we have a question, how long would the side of a square with an area of 64 square inches be? And so one way to think about that is to make a list of all the possibilities. And so if we had a side length of 1, we would have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. We'll just go to 10. 9 times 9 is 81, and 10 times 10 is 100. So if we had a square that had an area of 64, to get an area of 64, we would have to have, it looks like we can see right there, that to get an area of 64, we would have to have side lengths that were 8, because 8 times 8 makes 64. And it's square inches, and so our units would be inches. How about a square with an area of 9 inches? Well, we did that one on the previous page, but we also see that here in our list. An area of 9 would be a square that is 3 by 3. So we'd have a square that's 3 by 3. Its area would be 9. Side lengths would be 3 inches. Now, to get a little bit technical, we could say that the area of a square is the length of the side length times itself. So one side times the other side, which is really times itself. The other way to write that in a fancy math way is to use a squared symbol. That little elevated 2 there says s squared. And so we can, for a square, have a formula that says area is equal to s squared. If we know the lengths of a square, we can find the area. If we know the area, we can find the side length. So for instance, if a square has an area of 16, we know that the side lengths must be 4. We call 4 the square root of 16. And so what we've got to understand is that the area is going to represent the number that is squared, and the square root is going to represent how long one side is. So the square root symbol on a button, or the square root button on a calculator, looks like that kind of fancy crooked leg looking thing there. This one right here. And then we would put the number inside of it, and that would produce an answer for us. And so as an example, I'm going to pull a calculator up on screen here. And so what we've got is a square has an area of 121 centimeters. What is its side length? And so the area is going to be the side multiplied by itself, which means that we're looking for a square root. And so I can press this square root button on a calculator and put 121 in there. It's going to give me 11. So if we had a square that had an area of 121, the two side lengths would be 11. Another way to say that is that the square root is 11. So again, the square root is the side length of a square with a certain area. Now, how about if we had an area of 23 square units? And one of the things I want to do immediately right now is just get you used to this idea of estimating this. And so if we come back to our list, the 1, 4, 9, 16, 25, all that, we see that 23 is not there. It's somewhere between 16 and 25. And it's way closer to 25 than it is to 16. So I'm going to guess that this is going to be almost 5. And it's a good idea always to be making a kind of not necessarily a guess, but a prediction of what this should be, so that we're making sure that whatever we get makes sense. And so I put square root of 23, I get 4.795, etc. I'm only going to go to 2 decimal places. And so in this case, it's going to round to be 4.8, because that 9 is going to turn into a 0 because the 5 after it, and then that's going to round that 7 up to a 8. So, and then a square has an area of 90. So again, let's just run through that. This square had an area of 23. Its side length is going to be about 4.8 inches by about 4.8 inches. Now we have a square that has an area of 90. We're going to look at its side lengths by finding the square root. So the side length is going to be the square root of 90. And I should have estimated first 81 and 100. It's going to be almost exactly between 9 and 10. So I'm going to guess about 9.5. And I get 9.49 is what my rounded answer is going to be. So almost exactly 9.5. So our side lengths would be 9.49 and 9.49. Okay. Now these squares have their areas labeled. We're going to use what we know about the relationship between area and side length to find the side lengths of these squares. And so I see 36 there. 36 is in our list right here. That means the square root of 36 is going to be 6. And I can verify that with the calculator. Square root of 36 is 6. And so the side lengths of this square are going to be 6 by 6. If we look over at 30, I'll come up to my list so I can do an estimate really quick. 30 is going to be between 25 and 36, almost exactly between them. And so I'm going to guess between 5 and 6, it's going to be almost exactly 5.5 is what I think that should end up being. So square root of 30, almost exactly 5.5, 5.48. 5.48 is what our side lengths end up being. Then for 21, we've got square root of 21. I should have estimated first. It's going to be between 16 and 25, but just a little bit closer to 25. So I would say about 4.6. And so we see that that comes out to be 4.58. So 4.58 as a side length. And then so lastly down here at the bottom, the square root is basically the length of a side of a square with a given area. And so we can see there that we were given those areas of those squares. Those numbers around the outside perimeter there represent the side lengths of that square. Those are the square roots. I think that's the last page. Yep.